in case you're wondering, we did a little survey before you started of like and asked what role your interest is coming from. Of all the people who signed up, not all of whom are on yet, based on the numbers, 8% were building owners, 24% were concerned tenants, 12% were contractors, 20% were engineers, 6% were facility managers, and of the other, there were architect, general other, consultant, manufacturer, student, project managers, trade, tech, and a homeowner. So that just gives you a little sense of, who we are. Who your fellow people on those little squares that you can't see. One of the things that's kind of cool about Green Home is because we are all volunteer organization. If you're interested in signing up to get involved in careers or forums, we have this little fancy QR screen, QR code, where you can take a picture of this scan thing on the right, and it'll take you right to the page where you can sign up if you're interested in volunteering. Just amazing what technology does. So I just want to say one thing about how this forum got started. We noticed over the summer there are a lot of webinars that really focused on commercial measures that can be taken in commercial environments to combat or mitigate COVID. And we really, since we are Green Home, we really wanted to talk about what we, tenants, building owners, people, just regular people, what we can and can't do to help ourselves keep safe and our families. As I've been in my family and my friends, I don't think I know two people who agree as to exactly how they want to handle COVID, especially as Thanksgiving and the cold weather come up. So the run of show is that we will have 3 speakers, and then we'll have questions, and you can feel free to put your questions in the chat box. We want this to be lively and fun, if you can call it fun when we're dealing with such a serious topic. So first I want to introduce Dunstan McCauley, who's an engineer, a building systems practitioner with over 20 years experience in the design of engineering systems for the built environment. He joined SETI and Associates in 2018 as Director of Mechanical Engineering, specializing in the design of a variety of systems for commercial and institutional projects. He is instrumental in the firm's high-performing buildings practice. He is a graduate of University of Maryland and is a registered professional engineer in both New York State and District of Columbia. And he's also on the board of directors of ASHRAE as the Region 3 Director and Regional Chair. And I also noticed that he was on the board of directors of Center for Sustainable Development in Africa. Thus, his expertise and influence spreads from DC to New York and to parts much further away. So his influence and his expertise is global. So with that, Dunstan, if you can get your screen, we would love to hear from you. Dunstan, can you hear me?
Oh, thank you.
You know what? I have to stop sharing.
Okay, thank you very much. Thank you, Evan, and everyone for inviting me. It's my pleasure, and it's a great opportunity to speak to you this evening. So a little bit about SETI. SETI and Associates, we're a multidisciplinary engineering firm. We're headquartered in Washington, D.C., and we have offices along the East Coast, including New York City, Baltimore, Atlanta, Charlottesville. And we also have an overseas office in India as well. I'll talk a little bit about just some of the direction out there. I know ASHRAE has been very involved in providing direction. And it's like, where do we go to take our direction? I know, as Evan said, there's been multiple sources out there of information, and where is the best place? ASHRAE at the start of the pandemic established an epidemic task force to bring to the table experts in the field to provide guidance not only to the society, but to our members in general and to the general public. And this task force is headed by Dr. Bill Bonfleff, who's a past ASHRAE president, as well as a professor who has done his primary work in airborne transmission of viruses and so forth. So it's a team of extremely talented individuals, and they've been working nonstop since the start of the pandemic, just in terms of coming up with guidance for practitioners and building owners as well. ASHRAE was one of the first to come out to say that transmission of the SARS-CoV-2 virus is likely to be airborne, and that we had to start to take a look at our building operation systems to minimize the airborne exposure. And a lot of the guidance from ASHRAE is based on the precautionary principle: let's do as little harm as possible. As we know, and with this, we know ventilation, and if we're looking at our HVAC systems, ventilation, disinfection, and filtration are primary ways to reduce airborne concentration of the SARS-CoV-2 virus. Also, the CDC has a wealth of information focusing on intensifying cleaning, disinfection, and ventilation of the buildings. So just a little bit about the virus. Viruses can be categorized into three different categories: envelope viruses, and then large, such as the influenza A. And these are some of the easiest to kill. And then you have large non-envelope viruses, which like the rotavirus, which can be very difficult to kill. And then you also have a third type, which is a lot smaller and can, like the rhinovirus and norovirus, which are extremely difficult to kill. From a health perspective, or from our perspective, the coronavirus is an envelope virus, which actually makes it one of the easier ones to kill. So that from a disinfection perspective, that gives us a good opportunity to try and fight it. One of the things we've come to realize, the studies have shown that the first infection was potentially in a restaurant in Wuhan, China, where you had a very poor HVAC system. And the studies have shown that it was probably came from about 3 tables in the back of the restaurant. They had no ventilation. They had split systems, recirculating air, and it was only exhausting, and there were no exhausts. And therefore, the virus was just transmitted amongst the individuals at those 3 tables, and that's how the spread of this pandemic started. In terms of looking at how do you control your transmission, you have this hierarchy of controls where first one, the highest and most, and it goes from the top being the most effective down to the least effective. And the first one, elimination. So if you eliminate a source of the virus, obviously, then you're not going to have much transmission. And then you can go into substitution, trying to replace the hazard, which is a little bit difficult. And then engineering controls, and that's where we as building service engineers come in with our HVAC systems and how we can implement strategies to minimize the spread of the virus. And then all the way down to administrative controls, looking at how changing how we use the building, like the social distancing and so forth, or controlling who comes in and out. And then the least effective, which is the PPE, but in terms of controlling the spread. But in terms of implementing policy, it's actually trying to combine all of them to give you the best protection for the occupants. So one of the things to look at when we start looking at it is how do we control the spread when we start looking at things from an engineering control, and the items that we kind of look into are, controlling temperature and relative humidity, filtration, disinfection, dilution, which is bringing more outside air, and then air changes, just constantly flushing the space with new air so that you can utilize the other cleaning methods to provide a control of the virus. So one of the reasons why relative humidity and temperature is critical. Studies have shown that and a lot of this was done with the influenza A virus, but you see a significant drop in transmission once you start to get your relative humidity up to about 40%, so from 40 to about 70, 80%, it has a major impact on transmission. And that's why, and that ties into why you're starting to see an increase of spread, because as you start to get into the colder months, your relative humidity in your space and outdoors will tend to decrease, and therefore you start to get this higher transmission, as you can see with this curve. One of the things, just wanted to talk a little bit about the relative size of viruses. So if you think about it, and just to see how small it is and how difficult it is, and I'll talk a little bit more about this later on. But when you think about the size of a virus, you hear microns, and a lot of times it's hard to imagine how big 1 micron is. So if you think about it, the human hair is roughly about 80 microns, and the smallest particle that you can see to the naked eye is probably about 40 microns. So it just, the circles to the right of the screen, if you imagine that the bigger gray one is about 80 microns. This is the lighter gray one is about 40 microns, and that's the red dot is essentially what a particle 1 micron will be in relation to something that's 80 microns. So if you start thinking about it, how small something that 1 micron is, and if you think about most bacteria and viruses, they're in the range of 0.003 to 0.3 microns. So they tend to be really small. The benefit of that is one of the things when you look at transmission, most viruses will attach themselves to larger particles. So like dust that's in the airstream. So in terms of controlling it, and that's one of the ways how you can effectively fight it, because if you can start to control your particle counts in your space and control some of the other particles that the viruses are attaching themselves to, you then have an ability to arrest it. And those tend to be within the 1 to 10 micron range. So, and this is just to show a little bit about the ways of filtration. I'm not going to get into the engineering of it, but the main thing I wanted to talk about on this slide was you start to hear a lot about MERV 13 filters and a lot of recommendations that you use MERV 13 or HEPA filters and so forth. And one of the reasons why you start to see, one of the reasons why MERV 13 is starting to be preferred is when you start looking at your relative cost versus risk on this graph. As you can see, your MERV 13 shows a significant drop in risk versus cost. And going from MERV 13 to HEPA filtration, you're not really, it is better, but it's not as significant as going from a MERV 8 or a MERV 4. So from a cost risk perspective, MERV 13 is starting to end up to be that sweet spot for filtration, where you can get relatively good filtration without significant cost increase. From how do you fight the virus, you also have to look at ways of attacking the virus or killing the virus or modifying the virus structure. So some of the these are some technologies that are out there. The ones that are I would say are popular have been, and you hear a lot about, have been the UVC, which you can put in your air handling systems, or you can buy portable units with some UVC lighting. And then bipolar ionization. It's another technology where again, with the bipolar ionization, it puts an electrical charge on particles that the virus are going to attach itself to, and then it attracts it to contain it. One of the things, excuse me, and then you also have another type that's gaining popularity is photocatalytic oxidation, which again uses chemical filtration to capture and kill the virus. So these are some of the technologies that are emerging as when you start to look at attacking the virus from a disinfection perspective. Dilution is looking at, bringing more outside air. So ASHRAE has a standard for ventilation, and generally most buildings have a certain percentage of outside air. So one of the initial recommendations were, if we have the virus growing or multiplying within the space by bringing in more outside air, we then start to reduce that quantity within the space, and we can then start to lower the opportunity for it infecting others. So those are some of the key strategies that have been recommended. And then air changes, again, you start to look at a lot of the study says, and I'll show some examples. Generally, if I'm replacing my air within my space 6 times an hour, which means I'm taking it through my air handling systems or my building systems, I'm also replacing it with fresh air. So the more I take it through an air handling system, I'm replacing some with fresh air. I'm also filtering it. It helps me reduce the number of particles or the concentration of particles with infectious particles within the room, or the term called quanta. So the more I can reduce that quanta and how the better I can protect the occupants within the space and try to mitigate the risk of infection. So a lot of times we try to find ways to bring that down. And one of the opportunities is outdoor air. Just the more outdoor air we can bring in, the better our chance of trying to reduce that quanta. So one of the things we've done at our firm, we've developed a risk mitigation tool to help our clients understand what the risk is. And I'll go through an example at the end where we try to see what are some of the opportunities to implement strategies to help mitigate some of the risks. And the idea is just, systems are not currently built for this. So most buildings will have to put in some retrofits, and we're trying to help them understand how effective different retrofits and different system modifications will be in relation to cost. So the first part of doing that, and when you start looking at is, okay, you start to look at your systems. You want to, like I said, temperature and humidity are critical. So if you're looking at your system, you want to start to make sure that your system is maintaining proper temperature and humidity to help control the virus. You want to make sure your systems have been maintained recently, and you want to check that. And you just want to make sure that system has proper controls and working controls so it can be properly controlled. And then you just want to check your maintenance and see if things have been changed recently. Start looking at your filtration and looking to find ways to get the proper filters within your system. Other things that we do, and it's more for more on the advice that we give building operators in schools. It's less for the individual occupant, but you want to look at security protocols of who's coming in. And one of the things that we talked about is just have controlled entry points and exit points. So you minimize the opportunity of people coming in and going out at the same points. One thing that you can do, and we started recommending, is thermographic scanning. So you can start checking the temperatures of people coming in, and there's scanners out there. As you walk in, will quickly scan the individual to try and find elevated temperatures to give you some assurance that the individuals entering your building are healthy. We start asking them, and we start telling them to start to look into replacing filters, as well as coming up with and implementing some of the administrative controls about how do you come in and out of your building, as well as look at opportunities to do some PPE storage and evaluating waste stream. And then we start to look at how can we increase the outdoor air, because we want to dilute the airstream as much as possible. So from a big picture, and there are opportunities, we also recommend individual space controls, as well as large space controls. So generally, ideally, if I have a central system and I put controls and use my central system, there's less points of checking and maintaining than if I have individual controls. So, our first place to go is to look at your main systems, look at your main HVAC systems. And if you have, and a lot of newer buildings have dedicated outdoor air system, which is generally called a DOAS system. So if you have a dedicated outdoor air system that's continually bringing fresh air, that's a good thing, because then you can guarantee that you have good ventilation coming into your building. So we start looking at opportunities to put some UV lighting in there, or some bipolar ionization. We want to add humidifiers so that we can start to keep the space relative humidity above 40%. Again, so that's roughly where that your transmission rate starts to drop. And we want to start to put in isolation spaces, increase outdoor air, and look at better filtration within the space. And then we also want to start to monitor that a lot of those changes. So one of the things we've been doing is we've been putting in sensors within our tenant spaces. We're doing a major retrofit for the DC public schools, and one of the things we're doing is we're putting in these sensors. So we've increase the ventilation. So this is an example of one of the facilities that had a dedicated outdoor air system. So we kind of changed the system design so that it was constantly bringing outside air. And one of the downsides, especially in this interim period where we're trying to actively fight the virus, and this is a brand new virus, where the one thing that unfortunately is being sacrificed is energy. A lot of our systems were designed to be energy efficient. You had a mode of operation, your hours of operation. One of the things that we're doing is we want to make sure that the system, we're providing clean spaces for the occupants. So a lot of times what we're doing is we're increasing the number of hours that the system's being ventilated. So that way we're starting the system earlier, 2-3 hours earlier, so that it can fully ventilate the space before occupants come in, and we're running it a few hours later to make sure it's properly clean. So as I was saying, we're monitoring temperature and humidity, as you can see what this chart is saying. Obviously, this space, when this rating was, we had pretty low humidity, but we want to check what our temperature is, check what our humidity is, so that way we know what our risk factor will be. One way to measure how much outside air you're bringing into a space is to measure your CO2 levels. And if you look at the CO2 because people give off CO2, so what has been used in the industry in the past is to look at if I'm properly ventilating a space and bringing in outside air, I'm getting rid of the CO2 that the occupants are putting out, and that way my CO2 level will go down. So by looking at CO2 level, we can assure we provide some assurance that we're bringing more ventilation. I'll come back to the VOC, which is a strange point that we saw with this, but I'll come back to it later. And then we start to look at the particle counts within the space, just to make sure, again, like I was saying, the viruses attach themselves to bigger particles. So if we start to control our particle count, then we're showing that we're achieving the filtration rates and taking out the larger particles that viruses attract themselves to make sure that we're trying to keep that quanta down. And one of the things that we saw with VOCs was we started to see spikes in some of these facilities roughly when they were doing cleaning. So we realized that you can use this VOC counter, which was just part of the product that we were using, to validate that you are doing proper cleaning and disinfection. And whenever the cleaning crew went through and cleaned the spaces, there was a huge spike in the VOC. So that is another way of validating that you are doing the cleaning of the spaces to make sure you have a clean, healthy environment. So that's basically some of what we do. One of the things our primary goal is to, as we said, do no harm. We want to try and control the environment as much as possible. As we know, the likely transmission, part of the likely transmission is airborne, and the HVAC systems are great, are one of the better sources of trying to control that airborne transmission. That's all I have. Any questions or comments?
I think we're going to move on. So we saved all the questions for the end so that we don't run out of time, if that's okay with everybody. I think Tom's going to introduce Amalia.
Sorry. Amalia Quadra, who is a PE, is our second speaker. And she has this very long bio, which I could read you, but what I'd like to do instead is mention that I first met Amalia, oh man, must have been about a dozen years ago. And she was not in the energy efficiency game at that time, but she was looking to break in. And I remember walking up, I think it was Madison Avenue, and we're just talking about, you know, the energy biz and how can you get a toehold in this industry. And, you know, it's difficult if you don't have the specific background, blah, 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 blah. Well, as you can see, not that many years later, she's now the Senior Director of Engineering at the Npower Group. And her experience includes things like engineering design, controls and automation, commissioning services. And she now speaks widely on a number of different topics. She's spoken for the Mayor's Office of Sustainability, the Building Energy Exchange, Women in Sustainability and Energy, and others. Prior to her being with Npower, she was the senior manager of existing buildings with a firm that shall remain nameless for some reason, and also was an instructor at the 32BJ Thomas Shortman Training Fund for building superintendents. Dunstan, who just spoke earlier, lives in the Washington, D.C. area, but Amalia lives in Brooklyn. So she's a local, and I'm very, very pleased to have her speak with us today.
Hi, thank you, Tom. That is the best intro. And I think it's fair to say that when I first entered this industry, or I was trying to come into this industry, Tom was very kind with his time and his advice. And 12, over 12 years later, here we are. So thank you. And obviously, thank you, GreenHomeNYC, for inviting me for this talk, which is very important and relevant and urgent as we see New York City. Things are changing, and things are changing in our country. So it's time for us to continue to remain resilient. So with that, just a little bit about Npower Group. We're an engineering firm. We were founded in 2003, and we really focus on doing engineering designs or designing engineering systems that are both energy and carbon efficient, and we do a good job with that. We do a lot of multifamily work, but we also service commercial, educational, healthcare, and some of the other sectors that you guys see listed here. I'm not going to go through all of them. So I thought it would be important, since my talk really focuses on multifamily buildings, and I think you're going to see some of the same things that Dunstan talked about, but they remain to be critical and important. But I thought it was important for us to start with, why is ventilation critical? And really, once you start looking at the built environment, you really need to find a way to remove any indoor contaminants, right? So we talked about VOCs. Obviously, CO2 builds up as we're breathing out, and infectious aerosols like COVID. So it's really a critical and often overlooked component of building systems. And if there is a little bit of a silver lining with COVID, is that it's brought ventilation system to the forefront of our conversation when it comes to mechanical systems. When we have conversations with buildings, it's often about my boiler, my chiller, this pump, that pump, lighting, but no one ever brings up ventilation system until you bring it up to them and you tell them that it's important. And if they've heard about the ventilation system, it's because someone has been complaining that the fan is too loud on their roof. So I would venture to say that I hope that, maybe, a few months from now, when, we start getting our lives back, that these conversations don't stop, because again, ventilation is very critical. Indoor air quality through pandemics, I thought one of the things that was interesting for me to see as I was going through this process, as someone who spent a lot of time thinking about ventilation, trying to do more ventilation work, is that as COVID started, March 13th came on and we just knew it was hitting New York City. Me and folks in our firms and other ventilation experts, we just knew that there was a clue there. We knew very little, and so and with that, we kept going back to one of the important facts is that the ventilation was going to play a role in this discussion, and I like to think about the 1918 pandemic as an example as to how ventilation or even fresh air was critical to helping through what we were going through. So sorry if you hear screaming in the background, I apologize, but I have a 2-year-old who has a strong personality. Again, fresh air and indoor air quality, or in this case, fresh air has been really critical for helping us get through pandemics. And I think before I go on and talk a little bit about COVID, I think it's one of the things that I keep reminding myself, and is that with regards to COVID, is that we are still learning a lot of it. And in 5 years, we're still going to be learning something about COVID-19. And I don't claim to be an infectious disease expert. I just really know I understand enough to ask the right questions, and I understand enough to think through the lens of, yes, let's do no harm. So I wanted to put that out there because I always remind myself there's more to learn when it comes to where we're at today. So about COVID, like as I was saying, like as we're learning more about what was happening with the pandemic in the early days of March, one of the things that kept coming up to me was like, is this an airborne pathogen, right? So what we have learned, and as we discussed, it is an airborne pathogen, and transmission does happen through the air. And it is an infectious aerosol. So essentially, I think we've all seen to a certain degree this image, and whether we're talking, we're coughing, or we're sneezing, we are spreading. We could be spreading the diseases if we are infected. I think Dunstan, one of the things that Dunstan mentioned is that, ASHRAE was very early on during the pandemic was talking about an airborne transmission. The WHO was a little late in the game, and it wasn't until sometime in July where that was actually admitted publicly after 240 scientists asked the WHO to actually talk about airborne transmission and make it just more of a worldwide understanding that this is a very important pathogen. I think to that, as we're thinking about multifamily buildings, which is really like where I spend most of my time, one of the things that I think about is how could, or one of the things that has kept me up at night, like what are the different pathways that COVID can transmit through, within a multifamily building. And I'm not necessarily saying that this is a pathway. I'm just saying that this is something that I have wondered. And it because it aligns with what I do, I can't help but ask myself the question. And so one of the things I'm just going to bring up is in 2003, with a similar pathogen to COVID-19, there was the SARS outbreak. And in a very tall high-rise building in Hong Kong, Amoy Gardens, we had approximately a third of the 321 infections within this apartment complex came from a line that was vertically aligned. So when you have a ventilation system where, you know, the top floor is over exhausted, you know, you have your balance point in the middle that sometimes you get ventilation, sometimes you get air that gets pushed back. You know, you know, you have to wonder what's going on, or I have asked myself what is going on. But I'm not saying this is a transmission pathway. I'm just saying I have asked myself that question. But I think to that point is, in coming back to the point that ventilation is important, making sure that the ventilation systems are balanced, you know, is very important, and making sure that we are thinking about removing mold, and removing humidity from different spaces, from bathrooms and kitchens, and cooking smells are also very critical to indoor air quality of the residents that we serve. So to that, as we were within our firm, as we were getting prepared and thinking about COVID-19 in the buildings we serve, you know, following along the recommendations of ASHRAE, you know, they talked about ventilation, disinfection, and filtration. Turns out there's a really helpful acronym for us to think about those terms, which is CDC, right? It aligns with the Centers for Disease Control, but it's not. Right. So the first item is clean, which is like, let's clean infected surfaces and spaces, right? This is something that we've all been doing. Let's dilute the air of the buildings and reduce concentrations of potential aerosols and contain the viruses. So what does that look like? Right, for cleaning, obviously, we can continue to do filtration and EPA-approved disinfectants. That's also very important that we're making sure that any disinfectant we're using, it is approved by the EPA to do so. Diluting is about providing fresh air from the outdoors. And containing, are we removing, are we exhausting, are we the air that's within the space? So what does CDC look like? So I thought it would be helpful for me to talk about what CDC looks like at a personal level. And then it's easy for us to extrapolate and think about what that looks like for within our built environment. So clean, right? So that's the first step, right? Every single one of us is walking around with hand sanitizer in our pocket. Personally, I do not leave the house unless I have one within a 2 seconds reach. And every time I touch a surface, maybe it's a little paranoid, I do just clean my hands. The second component of that, obviously diluting. We are all trying to spend more time outdoors than we were before. This is critical. And number 3, we're all wearing masks, because that's one way that we can do to contain the virus, especially if the virus is coming from us, right? So there are many different types of masks out there. Obviously, you know, you can buy one from Louis Vuitton. You can buy one from Mooning. If no one knows, it's a really cute cartoon that I have cool Band-Aids from that my kids like to use. But also, depending on where you're at, you know, maybe you want to use a N95 mask, which is when I go into a building or the field, if I'm sharing the elevator with someone, I really like to have an N95 mask on. But if I'm just, you know, going to pick up my kids from daycare, then I'm okay wearing one of these masks. So what are the risks, right? So I thought, since we're having this conversation, rates are going on up within New York City and across the city. I thought, and you know, we talked about having a conversation about this, but really, if you are not containing the virus within yourself, if you're not wearing a mask and you're not providing fresh air to an environment, if there is a person in a relatively small living room, if you're there together for 4 hours, everyone in that room, this is in a study that was there is an article that was posted by El País, which is a Spanish newspaper from Spain. But basically it shows that within 4 hours, everybody in that room will be infected. Which is, you know, as we're approaching the holidays, I think this is very critical for us to think about. So this risk changes once everybody wears a mask and you have some form of ventilation, right? So within 2 hours, really that risk becomes very minimal. And I think it's one important thing about COVID that all of us should think about and should share with our friends, and that you can transmit the virus if you do not have symptoms. So as we're approaching the holidays, that's something important for us to think about. So within a multifamily building, going back to that discussion, like CDC, right? Dustin talked about mechanical ventilation, and he talked about using MERV 13 or higher filters. This is something that we want to make sure that we're doing anytime we're particularly recirculating air between a building. There are options for HEPA filters. I kind of like those for the standalone, particle cleaners, but they're also kind of pricey. And obviously, we talked a little bit about other filtration mechanisms like UVC lighting, photocatalytic oxidation, and bipolar ionization, but I'm not going to get into those details because I really want to focus on multifamily buildings. So one of the things that is very critical for us to think about when we're talking about multifamily buildings is that the majority of multifamily buildings, at least in New York City, really have primarily exhaust ventilation systems. And often the hallway unit, if it's not an exhaust system and there are no windows, then it could be a supply unit. And this supply unit is 100% fresh air. So the question is, do you need a MERV 13 filter for that? Do you need to change the filter? And in my personal opinion, I don't think it's necessary, but if you can get a hand on MERV 13 filter, then I think it's perfectly acceptable as long as your air handler can manage it. Now, within a multifamily building, there are other spaces that could have recirculated air, like gym, pools, community spaces, even lobbies. And those spaces, we really should be looking at some of the mitigation options that we have been talking about, especially starting with your filtration, making sure the dampers are working, making sure the controls are working, making sure that outdoor air dampers are working, and we're providing as much as fresh air as we can provide. This is going back to continuing with the conversation about an air handling system that has recirculation. I really tried to find a picture. Oftentimes when you look at a schematic of an air handler, it's like if you guys think of an H laying down, it's your typical schematic, right? So on the bottom left, what you have is you have your fresh air coming in. It's your outdoor air damper. Then you go through a couple of coils, and then you exhaust. Then from the space inside, whether it be an office space or a gym or an office, whatever it may be, you're returning some of that air, and then you're exhausting some of it. But you're returning about 80% of it, anywhere between 80 and 90%. Sorry. During COVID times, I don't know if you guys can hear the yelling, but during COVID times, we want to do as much as we can to dilute that space. And so we really need to start closing that mixed air damper, which is in the middle, We really need to close down the mixed air damper, which is, where it connects to the fresh air and the exhaust, and really try to exhaust as much as we can and reduce that. And obviously consider some of the other mitigation options that we're talking about, like additional filtration, UVC lighting, and as such. Given that these supply or these air handling systems are really not common within multifamily buildings, and we see them all the time in commercial buildings, I think it was really important for us to think about containment in a different way, which is like, how do we make sure that what is supposed to be extracted from a bathroom or a kitchen gets extracted out of the shaft and outside of the building? And really, we have done a lot of work on this. So we have focused on, historically, we have focused on helping buildings go from this, what you see on the left here, where you have a ventilation system that is not balanced, that it's leaky. You can smell your neighbors cooking, you can smell your neighbors smoking. And to a system where everyone gets exhausted the same amount of volume. If you're supposed to be if the top guy is getting 30 CFM, then the bottom one should be getting 30 CFM. Exhaust ventilation needs to be a democratic system, which is something that we don't have in New York City. The top floor gets about 200 CFM and the bottom floor gets nothing. And that's something that we really need to address outside of COVID. But like I said, COVID is bringing more attention to these types of problems. So with that, I wanted to, give you an example of a project that we worked on where we managed to do this. This is in the Two Bridge neighborhood of New York City, where we worked on 2 buildings, 26 stories each, about 62 exhaust fans. We did an exhaust ventilation study across multiple floors. And what we found is that obviously, and this is completely systemic across many, many New York City buildings, is that the upper floors are overexhausted, the lower floors are not. So as you go in the x-axis, you see the top floors 25. We're getting somewhere around 200 CFM, and the bottom like 0, right? But the majority of them are also below existing New York City code levels for mechanical ventilation. And then for some reason, a 25th floor had, 0. The same thing on the kitchen floors. We saw very high rates. And then we did manage to, for the most part, they were meeting existing mechanical ventilation codes. So what we found as we did our study, besides the tables I just saw, is that obviously there's poor duct conditions. Ducts were dirty with many gaps and holes. There were very poor register conditions, many registers blocked, higher flows at the top floors, minimal flow at the lower floors. We also saw in a lot of the kitchens that residents had installed inline fans that they were being duct into what's supposed to be a negative exhaust system. And the other thing that we saw is that some of the fans, the total volume of the fans were 15 times what you would think the total volume of the entire system was. They were like super oversized. Once we started to dig into it, we learned a couple of things. The ventilation system at this building is designed so there's what is called as a local line and then the express line. So the local line, what it does is serves the first, if this is a 26-story building, the local line would ideally serve the first 13 floors. And then the express line will go ahead, it's closed all the way through the first 13, and then the bottom 13 get exhaust ventilation. However, this building was being exhausted differently, where instead of being a 13 and 13 split, it was an 8 and 18 split. But then at some point, when they designed the system, or not designed the system, when someone replaced fans in the system, this size both systems to serve the exact same volume. So then both systems were designed to exhaust 100 CFM for 26 apartments. So fan A was serving 2,600 CFM, serving 18 apartments. And then fan B was exhausting 2,600 CFM, serving 8 apartments, which is, astronomically irresponsible from an installer to have actually done that. This is also a picture of someone who was exhausting into the kitchen exhaust. This is a big no-no. It's a code violation. It's also not fair because the person above may be getting some of that positive pressure. Again, ventilation systems need to be democratic as how they're currently or have been traditionally designed in New York City. So our scope of work was to do the ventilation study. And then we designed the upgrade, which was duct sealing and cleaning. We used Airseal for duct sealing. At the registers, we cleaned them, we sealed them. We installed fire dampers, and we also installed constant airflow regulators. And then we sized the fans properly. You'll be surprised how much of that gets you. And then we commissioned. Now, one quick note about the fire damper in this building is that after I think we were out of here like 3 months. And then someone decided to cook some kind of medicine, maybe, I don't know what else they were cooking, but it didn't work out very well. And there was a huge explosion that knocked out a wall, and then the fire damper activated and did what it was supposed to do. So I was really happy, obviously, about the fire damper working, but obviously, that's a sad story. Some of our post M&B work, it actually shows that, I don't know if it's easy to see here, but our post CFN measurement shows that at the lower, that we were targeting, or we matched our target floor rates from the top floor to the bottom floor. So it kind of aligns with the green line that you guys see. Overall, this project saw 90,000 CFM volume decrease across both buildings, and it achieved energy savings, and we also received rebates for it. So even though, I guess my point with bringing this up is that we know that that within the resiliency things that we need to do for COVID, we know we need to be thoughtful about how much fresh air we're bringing to the systems, but also some basic, simple engineering, making sure that your dampers are working, you're doing your maintenance on your system, that sometimes there are opportunities for energy savings. So we need to continue being on this path that we're on right now, to continue to be diligent and making sure that we're taking the right steps to mitigate and continue to bring fresh air. And obviously there's a big energy impact with that, but we don't really have an option. But where the options are is continuing to think about ventilation and continuing to think about where are the opportunities for doing ventilation correctly. So with that, thank you for your time, and I apologize for the screaming, because of course it had to happen while we were together, but I appreciate your patience for that.
Amalia, we love hearing real world happening behind you. It's all good. So I'm going to jump in and move quickly because we still want to have time for questions. I want to introduce Mina Agharabi, who is the principal and owner of Agharabi Engineering. She and her team have more than 50 years, she's only 23, I think, of combined, no, I'm just kidding, of combined field experience in the operations, commissioning, and troubleshooting of HVAC systems. I'm going to rush this a little bit. Mina is a voting member of the ASHRAE and on a lot of the engineering technical committees. And she has served as a contributor to the Mayor's Office of Sustainability and One City Built to Last. And she also teaches, and she's also a personal friend and mentor to me. And I appreciate her so much. And here we go. Thank you, Mina, for participating.
Thanks, Evan. So I'm just going to jump right in because to keep things on track. Tonight, I'm going to talk from the occupant's perspective. And I lived in a variety of different types of multifamily buildings, and majority of them receive natural ventilation, and only a few of them had exhaust in the bathrooms. So the key points I want to try and get to in this presentation are how you can alter the spread and direction of airflow into your space. Talk about how you have to have a pressure differential between your space and the outside, or wherever you're trying to bring in that outside air. And then move on to talking about, I think I saw someone mention a question about corridors. So I wanted to give an example. If you do have a corridor, how should you bring in that outside air? And then briefly talk about monitoring outside conditions when you're operating your openings. And then lastly, just quickly go over a couple of things with regards to ACs that most people don't realize, that they only recirculate your indoor air. They don't actually bring in outside air. So most common, what you see in apartments is a double hung window. It's important to note, no matter how you open it, it's only going to be half the window area. The other thing to consider is the location of that window in your wall, and is it located to maximize prevailing winds? Meaning, I've plenty of times I've burnt something on my stove, and then I've run to open the window and no air is coming in because it's absolutely dead outside, and the smoke smell remains forever, and it's really aggravating. In terms of room pressurization, so what I'm talking about is having your space negatively pressurized relative to the outside, so that the air is flowing from outside to inside. And in taller buildings, I don't know if people are familiar with stratification, but in taller buildings, when you open a window, the air tends to flow out and not in, versus in lower floors, air flows in. So understanding where your room is located and whether what its pressurization is relative to where you want your outside air to come from. Another thing I've been thinking about is a number of people have railroad style apartments. So you may have a window on either end of your apartment, and if you close the doors to those rooms, that will mitigate air reaching the interior spaces and cause stagnancy. And then lastly, when you're opening and closing your windows, you want to keep in mind, what is the outside air temperature? What is the humidity? Because if you're opening it up, you may be just letting in more humidity than you really want, and then you're going to just feel damp and uncomfortable. as well as you might want to make sure that you have some sort of shades so that solar gains aren't overheating your space while you're operating your window. So other types of windows, you got casement, hopper awning, and those allow a greater amount of air to flow into your space. And this is just an example showing how other kinds of windows you can manually adjust them to regulate the direction of airflow and the velocity flowing through your space. Now, in existing buildings, this is kind of fixed, but it's just trying to, this is just trying to explain to you that depending on where the placement of the window in which you're opening to let this air in, and then if you're able to have another window in your space, either on an opposite wall or on a diagonal wall, that you want to keep your air inlet opening lower. So if, let's say this is a double hung window, you would want to open the lower sash, and then on the outlet position, you could either open your lower sash and or upper sash. If you have other apartments where you may have higher windows placed someplace, or you're able to install a fan, it might be ideal to have a supply fan here, an exhaust, and same thing, a supply and an exhaust to try and move air through the space. So continuing the discussion of cross ventilation, this is a bird's eye view, or looking down on a space. And so in order to alter the direction and the spread of air through the space, we're going to talk about location of the openings, and then how if there's any interior walls that you may have dividing up your living room from your kitchen, all of that, as well as your furniture and how that will impact the flow through your space. So ideally, if you have perpendicular walls, you want to have your openings or your windows at the opposite corners. And then additionally, you want to have your openings, if they're on a diagonal on opposite walls, and also having prevailing winds that will then push air through from one end to the other. So I mentioned talking about window variety of air conditioners. So window ACs and through the wall ACs are the most common ACs. Oops, sorry, I'm trying to get rid of this notification thing. So these types of these types of air conditioners, they're designed just to recirculate. There are a few that have an outside air option, but majority, they're just pulling air in from the bottom and then conditioning it and dumping air out from the top. And so here it's just showing that this is the inside, which is what you see in this photo. And then this is the outside, which is on the other side of this window. And so air is flowing across this to allow rejection of heat to the outside. And this side is what's conditioning and cooling air and throwing it into your space. So with that in mind, since this is only recirculating, it's really important that you maintain filters and use the filter that's specified by the manufacturer, and maintain the inside and outside of the components just to make sure it's operating efficiently. Fan coil units are pretty much the same. They just recirculate air. Something that I have in my apartment that I use is a dual fan. It has two fans basically, and there's a switch. And so you can have it either all exhaust, all supply, or have one fan exhausting and one fan supplying. Note though that this is unfiltered and unconditioned, and it's only meant to serve a certain size space. For people that have a window AC installed, this would assume that you would have a second window that you would be able to use. PTACs, they also only recirculate air. They have a small louver at the bottom that you can manually switch back and forth to allow unfiltered and unconditioned air to enter the space. But most people, because it just lets the cold air drop in in the wintertime, most people just keep that closed and don't use it. And again, you want to make sure that you maintain you keep the filters clean, all the components inside and outside maintained for optimal performance. And then also you want to consider the layout of your furniture, because you want to make sure you're able to pull the air in so that it can be conditioned and then supplied out to the space. So let's say your window opens to an air shaft. There's a number of things you should consider. There's noise, but also if this is your apartment, is this your neighbor's apartment? And by opening a window, is there any potential for cross-contamination of air? The other thing is pigeons tend to live there, and there's poop, and you don't want to breathe that in. I don't know how much movement of air there is, so I don't know how clean or fresh the air is. People with asthma, there's dust and debris. And then also, you'll notice here, people have air conditioners. The air conditioners, the way they work, they reject heat to the outside. So by opening up your window, you're opening it up to an area where heat may be trapped. And so you might not get the quality air that you're looking for. I'm not going to go too much into this, but your space may require a humidifier, dehumidifier, and it's important to note that the controls on your air conditioner are such that it operates to maintain a temperature. It doesn't operate to maintain the relative humidity in your space. And these are just, this is a scenario I wanted to show with people about emphasizing how you can go to the hardware store and buy basic equipment, materials to do air sealing of pipe penetrations, gaps, and other things, as well as caulking your windows to reduce uncontrolled airflow between apartments and between your corridor, weather strip and door sweep your apartment entrance door. And the idea is you want to open and close your windows to allow control. You want to control the air entering your space. You don't want uncontrolled air moving from other spaces that you don't know whether it's if it's clean or not. And then lastly, there was another scenario would be if you do have a 24/7 exhaust fan running, and you do have your corridor is such that someone has verified that all air is has been filtered or conditioned, and this is clean air coming from your corridor, then you would want to do the same air sealing, because you don't want transfer between your neighboring apartment and your apartment, but you'll be pulling air from your windows as well as from the undercut in your door from your corridor. But again, this depends. You have to work with your building owner to look at what is the quality of the air in the corridor. This is just talking about the need. What I mentioned before, some spaces you might want to put an air purifier if you're going to be bringing in a lot of outside air in an area that maybe the air isn't so clean. So I just wanted to say thanks, and sorry it was fast, but I figured let's get the discussion going, and I can go into more detail with any of the things I've mentioned. Thanks.
I've lost my screen. There we go. Sorry, I lost my screen. I think we had some questions on the chat. Tom, can you take the ones that are in the chat while I look at the ones that were in Liza's email? Oh, you have to unmute yourself. There you are.
Sorry about that. There weren't a huge number of questions so far. Maybe more will develop as we move ahead. Questions that I saw, two of them were sort of related to each other. One was, what types of HVAC systems are compatible with MERV 13 filters? And another question was, how does HEPA correlate to MERV in terms of efficacy? And how would you deal with that in a multifamily building, and what is the cost? I think I can answer these two questions myself, which is that, and somebody actually mentioned it in I think it was Amalia in one of her slides, that there are MERV 13 filters that are available for HVAC systems, central HVAC systems in commercial and large residential buildings. And then there was another slide, I think it was Dunstan had a slide that showed that from a cost benefit perspective, MERV 13 was almost as effective as HEPA, but was much less costly. So I think the message there is, if your building has this type of a system, it is possible to install MERV 13 filters, and they are less expensive than HEPA filters. Amalia or Dunstan, do either of you want to add to that?
Yes, I'll take. So MERV means minimum efficiency reporting value. So it's stating how efficient the number of particles, what percentage of that size particles it's going to arrest. So so for example, if you look at a MERV 13 filters, it's saying particle sizes of about 0.3 and larger, it's going to stop about 95% of them. When you get into your HEPAs, which is high efficiency particulate filtration, is HEPAs start at 99%, so 99.9%, I think, is the lowest HEPA, and each upgrade of HEPA is another point. So it goes from 99.9 to 99.99 and to 99.999% efficiency. So that's the difference between a MERV 13 and a HEPA filtration, HEPA filters. So it's obviously HEPA filters are because it's more efficient. Also has there's a correlation with energy usage, because it's going to take more energy to move the air through that HEPA filter, since it's much more dense to block more particles. And then also, because it's more material, it tends to cost a little bit more as well.
Can you say a word? I know you had recommended a HEPA filter that I think covers about 300 and some square feet. Could you say it? Because I'm assuming that a lot of multifamily dwellings don't have they're really just operating on their windows. And
yes.
So I'm thinking of the holidays. I don't know if people want to, deal with this, but we have a holiday coming up, and, I know some people who are spending it alone, and some people are just having 10, 15 people over. And so I was wondering what you thought the use of, say you had a small apartment and you wanted to have 6 family members over, but that were not in your pod. Would you consider getting one of the filter that you recommended that, is maybe covers this, 300 and some 60 whatever square?
Yeah, there are multiple products out there. Obviously, the product that it's a small filtration unit. You can find it on Amazon or anywhere, that essentially covers about 400 square feet. One of the reasons why I like this, we have them in our offices as well, and that's what we use in our offices for the private offices, and some of the smaller conference rooms. It has we talked about different types of disinfection. Both Amalia and I talked about the UVC and the bipolar ionization at two methods that are currently used for disinfecting the air. So these units most of them tend to have both. Will have the bipolar ionization and the UVC. So you're getting two means of trying to disinfect the air. And then it has a HEPA filter on it as well. And then it ties back into what I was saying. So it tells you what your temperature and relative humidity is. On most of the units has a display with a temperature and relative humidity. So you see what the temperature and relative humidity is in your space. It has and then it also has a particulate counter. Again, that particulate counter helps give you some verification that you are cleaning the air. You know, and since there's no method of testing, for the virus and so forth in the air, you have to implicitly validate that you are doing some cleaning by, if you're arresting the particles that the virus are going to attach itself to, and those particle counts are coming down within your space, then implicitly you are cleaning the space. So that's one of the reasons. There are other units that's on the commercial market. There are some manufacturers, and I can send a listing out, that has units that are made for room type unit that has, just some filters and UVC lighting in them as well.
I did want to go back to the filter discussion. I think one word of caution, and I don't know if you guys caught this on Dunstan's presentation, but when they're upgrading air handling systems to handle MERV 13, it also said, with motor replacement. So a higher, most air handling systems are typically designed to have a MERV 8. Obviously, once we jump to a 13, what that includes is a higher pressure drop across the air handler, and that air handler may not be designed to be able to handle that pressure drop. So then you're kind of, you may be limiting the amount of airflow that's actually being delivered because you increase the pressure drop so much. So the word of caution there too is don't just put in a MERV 13 or HEPA filter. You have to do the background homework to make sure that that air handling system can manage that filtration, the filter change. So I just wanted to make sure we talked about that, because I think it's very important.
I think, yeah, that's a great point, Amalia. It's and a lot of times what we find is, newer systems may be already designed for MERV 13 or could handle it, and you have to check to make sure your fans can handle it. One of the things that we found that is possible, and you start to see it is, for example, if and that's why you need to take a holistic look at your system, because, so for example, if you have an older system that wasn't designed to handle a MERV 13, and it may not be capable of even doing the motor replacement, easily doing the motor replacement to upgrade to a MERV 13. So in that instance, you may want to look at, maintain your existing filters. The filters are still doing, it may not be as effective, but you're still doing some filtration. But then you may have to look at incorporating other technologies, more disinfecting technologies into your system, because, you can't just do it with filtration, so you may want to look at the UVC or even the bipolar ionization or one of the other technologies out there, just because, you can't have that higher level of filtration.
Yeah. I don't know that I think we sort of walked around it, but I was in my bathroom not too long ago, and I looked up and I saw that my own bathroom vent was like dirty, and I was like, okay, I'm an idiot. I need to vacuum this. So it may not prevent me from getting COVID, but it's just basic cleanliness practices that we all need to, that maybe God willing, when we're all past these times, that will pick up some better, hygiene. Just clean our air filters. Even if we can't get a MERV 13, maybe we'll at least clean them or change them twice a year like we're supposed to. But another question that we have here is, can somebody talk a little bit about COVID ventilation in lobbies and also laundry rooms, basement laundry rooms?
Yeah, so go ahead.
Go ahead. No, go ahead.
Okay. I was going to say, a lot of it too is going to depend on if the lobby has, let's call it natural ventilation windows, or if it has some type of recirculation system where an air handler recirculates 80% of it. So I think a recommendation, or at least my recommendation, would be, if I was maintaining a lobby, I would definitely put in one of those standalone HEPA portable filters. But also, if there's an air handling system associated with it, then I would follow the recommendations that we've been talking about, which is basically first step 0 is making sure that all the components are working as they're supposed to be working, temperature and humidity controls and so on. But putting in your, trying to increase your filtration, MERV 13 and above, and obviously putting in additional mitigation strategies as we discussed.
Yeah, I would echo those points. And, especially with lobbies, that's where we are making sure that we put in disinfecting technologies to because that's your central point. Everyone's coming through your lobby. So you have a higher risk of impacting, all your building occupants from your lobby. So you want to make sure that you can try and mitigate that as much as possible and control and try and control it as much. So, we definitely look at entry points. And I talked about the thermal scanning, for office buildings, even for schools, that's some of what we're recommending. Another thing that we recommend, for a lot of lobbies are walk-off mats, because, there are studies that have shown, the virus can attach to your shoes. So these mats allow you, as individuals are coming in and out, to capture it on the mat. It's a pretty low cost upgrade to the building that the building can easily put in. So put in some walk-off mats at your entry point, and anything that's potentially coming in on somebody's shoes can be captured there.
Cool. So we have 2 more questions, and it's 8:03. So can we? I'm going to just take the liberty of just throwing them out. Okay, this one's a little long. So regarding an ERV energy recovery ventilation system situation in a recent renovation of a 6-story building, whereby the architect developers placed the vent in an apartment below about 6 feet from the ERV on the roof above. Constant noise coming out from the vent. Very low as maybe 70 decibels. Are there any thoughts on this? Common sense dictates that the vent should have been installed much farther away. Any thoughts on this?
It's a challenge. It's always is a challenge, just because, when you have a piece of equipment on the roof, generally multifamily tends to have vertical distribution. So it's, those top units, you have to be very careful. Top floors always have to be very careful. I mean, ideally, you would put in some sort of sound attenuators to try and arrest some of that noise. Put in, see, you know, the ductwork should somewhat be lined. Ideally, you would try and have that first outlet further downstream from the unit to try and have the ability to attenuate some of the fan noise. So, instances like that where we go in and look at it, most of the time we'll recommend some sort of a sound attenuator in the duct to help arrest, break up some of the sound noise that's traveling down the duct.
Evan, I'd like to just interject here. It is after 8 o'clock, but those of you who wish to stay and those panelists who wish to stay, as long as the Zoom can continue, I myself am happy to continue and help answer questions and so forth. Those of you who turn into a pumpkin at 8 can, of course, feel free to drop off. I'd like to focus, Evan, if I could, on questions. We've gotten a lot of questions, and Liza has been tremendously busy answering most of them, for which I'm very thankful. But there's one question, a couple of questions here that I think are of general interest to the group. One of the things that was pointed out a while ago is that most buildings in New York City most multifamily buildings don't have ventilation. Certainly very few have like hallway ventilation, that sort of thing. Some have bathrooms and kitchens, but many, like for example, the building I live in, have no mechanical ventilation. And so those buildings, obviously you don't have to worry about MERV or any of that stuff because it's not applicable. And so the question becomes, well, what are the solutions in that case? I think Mina's presentation began to talk about that with the dual fan and so forth, or the cross ventilation, sticking a box fan in one window and having it blow out, and perhaps having a box fan in another window across the room and having it blow in so that you get that transfer of new air. The problem, of course, is that as the weather gets colder and colder, your ability to bring in enough outside air to dilute enough to stymie the virus could be compromised. Of course, this may be the winter that we're all so grateful that our buildings are grotesquely overheated, because it will allow us to bring cold air in without feeling anything. But does any of the panelists want to comment on strategies that people can use, especially over the holidays, to keep the virus at bay in buildings that don't have mechanical ventilation?
I would say look at the personal air purification units. Just get a couple for your apartments, or so at least you're trying to treat the air. It provides disinfection and some filtration. So you may not be able to get the ventilation and air changes, but at least the goal is you want to keep down, like I had said, the quanta. If you have people over and someone is ill and they're putting off the virus, you want to have some ability to control it, capture it, treat it, and so that you keep that quanta down and stop it from spreading, and so forth. So at a minimum, I would say, that's a pretty low cost solution, and we have a few units in our home as well. It's pretty inexpensive way of providing some method of treating a space, especially come wintertime.
Anyone else want to comment? Okay.
I was just gonna say, Tom, that I personally, I will continue to do all my socialization outside of the house. So obviously, the holidays are gonna be a little bit rough, but I think it's the best thing I can do for my family.
So with that, I want to thank everybody, amazing speakers, and it was really eye-opening. And I hope everybody has a safe Thanksgiving and holiday, and sign up to come to our forums and our careers. And thanks so much to Liza. I don't know if you guys looked at the chat transcript, but she has a gazillion resources there. So take a screenshot. And then we'll probably try to post it on our website at some point. I'm not sure how that will work, but look for it. Okay. Thank you so much, Amalia, Mina, Dunstan, Tom, Liza, Salmata, and everybody for coming.